All right, guys, today we got frequency distributions. Finally get to look at some numbers. Been waiting on this a long time. So frequency distributions shouldn't be too bad though. This is very important. Before we get to the frequency distribution, some characteristics. When we start looking at data, which we're going to start doing pretty much every day, certain things we're going to be looking for a lot. One is, what is the center of the data? We're going to find some value. Usually the mean or the median is near the center, but we need to know where the middle is located. The second thing we're going to look for is variation, which just means how far the data spreads out away from the mean. How spread out is the data? How does it vary? The next thing is distribution, which we're doing a frequency distribution today, which is going to be the shape or the nature of the spread. As the variation spreads out, what does it look like? And we're hoping, to be honest, a whole lot. We're looking for bell-shaped distributions like a lot. The last word is outliers. Outliers are numbers that vary. They just lie very far away from most of the other numbers. If you see one number that just doesn't make sense, we're going to have to ask ourselves why that's happening a lot of times. And one sentence here at the bottom. We'll be focusing on these characteristics and doing some manual calculations. We're going to do stuff by hand, but we're doing lots of tech calculations. However, even though we're doing calculations, we're mainly trying to make sense out of the data that we see. So that's our main goal in statistics, is figuring out what we can say due to the fact that we have this data. Okay, frequency distribution, which is today's topic, or table, so it could be a table, basically shows how data are put in several categories or classes. We're going to use that word a lot, classes, by listing the classes or the categories and the frequency of how many times the data value falls in. That's kind of a weird, hard definition, but it's the real definition. I'll be better off just showing you an example. Let me show you just an example here on the next slide. All right, what we have here is IQ scores of people who've been exposed to lead, either low levels of lead or high levels of lead. Hopefully you'd be in the low category, but lead level, that is, not IQ. So what I did here, or what I've done, taken a picture of, is all the numbers in the low level group, which is a lot of numbers, right here, all those numbers. And a frequency table is this right here. And basically what it does is it gives you information on how many people in that table of values have an IQ score between 50 and 69. There's only 2 of them. How about 70 to 89? 33 of them. 90, 35. This one's 7. That one just 1. I want to say 2 things about this table. This frequency distribution is very important. That'll be even more important as we advance. The first thing that's kind of weird that you may not notice is these intervals right here are actually intervals of 20. I know they look like they're 19 because you're like, 69 minus 50 is 19, and so on and so on. But you have to count the 50. If you start counting at 50, 50, 51, 52, 53, and you count all the way to 69, you're going to find out that you counted 20 numbers. That's actually 20. That's going to be important as you set these things up. Also, this is the huge thing. When it works out like this, when it's small on the edge, the numbers are kind of small on the edges, and it gets the larger numbers are in the middle like that. That's what we're going to call a normal distribution. As you're going to hear that a lot the whole year, normal distribution. Or if we were to graph that, it'd be like a bell-shaped curve, and we'll do some of that probably this week later. But bell-shaped or normal distribution when the middle's big and the outsides are not very big. All right, a few words you need to know too about frequency distribution. First of all, lower class limits. These are all called classes over here. The intervals that you made. The lower class limits are obviously just the lower numbers, the 50, the 70, the 90, the 110, the 130. The upper class limits are just what you would think. They're the upper end, the 69, 89, 109, 129, 149. So lower class limits, upper class limits, exactly what you think they are. Excuse me. Class boundaries. If you notice, when we go 50 to 69, let me pull, I don't think I can make it any bigger. Look at this chart right here. But when I go 50 to 69 and then skip to 70, I actually skip some space in there, or there's a gap. So the numbers that fill in that gap are called class boundaries. And basically what we do usually is we just take half, the midpoint between those two, and that's our class boundary. Even on the upper end and the lower end, we go half away and say, okay, the lower boundary is 49.5, the upper boundary is 149.5. So the halfway point in between the two, we're going to call class boundaries. Class midpoints, we're not using these a whole lot, but the class midpoint are just, the midpoint of the classes. So it'd be like right here. To find out what's halfway between 50 and 69, all you do is add up 50 and 69, divide by 2. You should have done that in geometry, find the midpoints. Add those up, 70, 89, divide by 2, and you would get 79.5. Or these are just the midpoints. Class width is a huge deal. You're going to have to find a, the width before you set these things up. All it is the difference between two lower class limits. So the class width, the lower, this one's 50, that's 70 and 90 and 110. The difference between all of those is 20. So the class width is 20. Now, we're going to construct one in a minute, and one of your jobs is going to be to find the class width. And it's right here. Here's how you make one on your own. What's going to happen tomorrow when you come in is I'm going to give you sets of data and have you make your own frequency distribution. So first thing you do is you select how many classes you want, usually between 5 and 20, and part of that depends on how spread out your data is. And we'll talk about that tomorrow. Number 2, figure out how wide you want your classes. And here's how we're going to do that. We're going to figure out our class width. We're going to take the biggest value in the data, subtract out the smallest value in the data, and just divide that by how many classes we have. And usually it's not going to come out even for obvious reasons, so usually we're going to round up to make it work really well. So that's how you choose class width. Then we're going to choose where to start the first lower class limit, and it's either going to be the minimum value or it's going to be something that's real convenient that's just really close to the minimum if it's not the smallest one. Number 4, using the lower limit and the width, we got to figure out the other limits. That's not hard. That's easy once you get to number 4. Number 5, list the lower class limits in a vertical column, and then figure out what your upper ones are by just adding your width. Number 6, take each individual data value, count them up, and figure out how many tally marks go in each slot for the class, and then just write the total frequency. Just add the numbers. That's a lot of lines, a lot of stuff. Let me just show you one real quick. All right, a lot of colors on this slide already, but what I did is I took a picture of the high lead level people. Only the high. Earlier we looked at the low. This is the high people. That are exposed to the high lead level. So the study would be to see if their IQs were lower than the low exposure, but that's for later. Okay, I determined how many classes I want. I told you earlier in the video, it's usually between 5 and 20. Because there's so few data points here, I'm going to go with the smaller one and go with 5. So to figure out what my width is going to be for my classes or my intervals, you may want to call them intervals, you take the biggest data value minus the smallest data value and divide by how many classes you want. When I did that, I got 5.8. And it'd be silly to looking at the data, there's no decimals. It'd be crazy to have class sizes that are 5.8. So I rounded it up to 6. Now here's the weird part. Where to start? Where do you start your first value? I looked at the numbers up here and I circled. My yellow circles you see right there are the, like right here, that is the lowest value. That's the highest value. So I'm like, okay, 75 is a pretty good place to start actually. So I just took the 75. I knew my class width had to be 6. Now here's the weird thing, I'm gonna keep saying this, 75 to 80 is actually 6 because you count the 75 and you count the 80, so that's 6, which means the next class is 81 to 86. So the classes are gonna look like they're 5 wide, but they're really 6 wide when you count both ends, both boundaries, so be careful there. And then all I did was this, I took the 75 to 80s and I underlined them all in red, counted them up, got 7. I found everything 81 to 86, underlined them in green, counted them up. Same thing, 87, 92, I underlined in blue, counted them up. 93 to 98, underlined in yellow, counted them up. 99 to 104, and the 104 just happened to work out. That was the last class. That's kind of weird, but not exactly, so pretty good. And that's how you set up a frequency distribution table. Frequency distribution table, and we'll work on that in class tomorrow. Hopefully not bad at all, and I'll see you there. Look forward to it. Bye.